Hello, everyone. We are ECE Senior Design Team 3, Accelerometer Sensing Pack, and our project is sponsored by Kimberly-Clark Corporation. Kimberly-Clark is a company that produces mainly paper-based consumer products with brands including Cottonelle, Huggies, and Kleenex. In order to continue improving their product packaging and product life, Kimberly-Clark wants to be able to conduct shock and vibration testing and needs a device to collect the data. For our project, we were tasked to design and assemble an accelerometer sensing pack that could collect data for a specific amount of time without any user interaction during operation. The device was required to be battery powered and collect data at a given resolution for a specified amount of time. Kimberly-Clark gave specific metrics to meet for these requirements, but has asked the team not to share them. In order to meet these requirements, the team designed a printed circuit board and wrote the code for its operation. A block diagram of our final device is shown here.
In the design process of the accelerometer sensing pack, we identified three crucial components: the microcontroller, memory, and the accelerometer. When selecting the microcontroller, prioritization was given to features such as low power modes and overall energy efficiency, alongside comprehensive documentation to make development easier. As for the memory component, a non-volatile solution with minimal power consumption was considered for its role in data storage. Furthermore, the accelerometer was required to meet resolution standards specified by Kimberly-Clark while also offering low power modes and overall energy efficiency. When working on the software, our focus was on developing a finalized code capable of initiating upon the press of a button, extracting data from the accelerometer, and storing it onto the memory device. Additionally, we aim to use the sleep mode functionality of the microcontroller and the low power mode of the accelerometer to optimize energy efficiency. To achieve this, our team divided into two groups, one dedicated to the memory and configuration file aspects, while the other focused on the accelerometer integration. Ultimately, through collaborative efforts, we successfully integrated these components to produce a functional codebase.
Throughout this project, we've accomplished most of our goals set by our sponsor. Some of the major achievements include collecting data at the rate specified by our sponsor, confirming that our memory solution is power safe and can provide an output file with the data it has collected, establishing low power mode operation for all major components, having a first draft of our board manufactured and assembled, as seen on the right, and some basic troubleshooting of the first board revision. While these achievements meet many of the requirements set by Kimberly-Clark, there are still a few more goals that need to be reached. To do this, it is recommended that a second revision of the final board be created. Some revisions to be made include a larger battery connector, dedicated header pins specifically for a Sager J-Link debugging tool, optimizing components such as switches and buttons to minimize board size, and more. Once this second revision board is printed, further troubleshooting and testing will need to be performed to confirm that all major components can communicate with each other and that the battery life meets the specified criteria. Thank you for listening to our video presentation.